So Jax wants to rent a car from the rental company, and the company charges $100 flat fee plus 25 cents a mile. Let's see if we can take this information and put it into a mathematical formula so we can figure out if it is in fact a function, and then if it is, so we can identify the domain and range of this function. So what does it mean to be a flat fee? That means that if Jax rents the car, it's going to cost him $100 no matter what. That means if he rents the car and it never leaves the lot, it's still going to cost $100. The next thing is a mileage fee, and that's 25 cents per mile. What does that mean? That means that if Jax drives 1 mile, it's going to cost 25 cents. If he drives 2 miles, it's going to be 25 cents times 2, or 50 cents. So 25 cents per mile. And just in words, what can we do with that? Well, we know that the $100 if he drives 0 miles. So let's see if we can break this down into a table of values. We need our inputs and our outputs. What is going to be our independent variable, or our input? What's going to be our dependent variable? Well, the one thing that doesn't change based on the cost is the mileage, right? So the cost changes based on the miles, which means if he drives 1 mile, it costs him an additional 25 cents. If he decides to drive 4 miles, it'll cost him an additional $1. If he decides to drive 10 miles, it'll cost him an additional $2.50. So our independent variable is the amount of miles that he drives. Based on the problem, it says the amount of miles we're going to call x. And most of the time when we're making our own equations, our dependent variable is going to be x. The independent variable is going to be x. The dependent variable is going to be the amount of money that the rental car company charges Jax in return for driving the car, which means the more miles he drives, the more money it's going to cost. So this is going to be the cost, which is our y variable according to the problem. But also if we're using x for an input, it's pretty common practice to use y for our output. Now what happens if Jax drives 0 miles? That's where that flat fee comes in. The flat fee is independent of the mileage, which means Jax is going to be charged $100 if he rents the car and goes nowhere. Now that's crazy. We all know if you're going to rent a car, you intend to drive somewhere. So now we need to start adding on the mileage. What happens if Jax drives 1 mile? Well, that 1 mile is going to cost an additional 25 cents, but that 25 cents is on top of the $100 that's already there. So $100.25. And if he goes 2 miles, it's going to be $100. And, well, what's 2 times 25? That's going to be 50 cents. And we can keep going. I'm going to skip some now. What happens if we go 4 miles? That would be $101.00. And because I already said it, let's go to 10 miles. Well, how do I know how much 10 miles is? Well, so far we know it's that $100 fixed cost, right? So let me do a cost equation over here. Cost equals $100 plus 25 cents times the amount of miles, and we're calling the amount of miles x, but I'm going to do times the amount of miles that we have here. So to figure out our cost is going to equal 100 plus 0.25 times 10. Now the nice thing about 10 is you only have to move the decimal point over once, so that's going to be 100 plus $2.50, or the cost is going to be $102.50. So that's going to go down here. Now we have a good set of table of values. We can even write an equation from this, given our information that we just used off on the right. And we'll get there in a second. First, we have to determine if this is in fact a function. For each of our inputs that we're plugging in, are we getting exactly one output? It doesn't even matter what that output is, as long as we're getting one output and not 2 or 3 or 4. So for each value I plug in, we're getting that one output, which means this is, or at least this looks like so far, a function. Now let's think. Does it matter if I go further mileage? Will it change the fact that I'm still getting one cost? Well, the cost is one set fee per miles. So 25 cents per X amount of miles. Every single time you increase your miles, that fee is going to be different. So we're going to get that one output for each of our inputs, which is exactly what we're looking for, which means this is in fact a function. So this relation, and we will write that now, the relation of, what should we call that? The relation, comma, cost of rental car per mile is a function, and actually it's just cost of rental car, it's not even per mile. So cost of rental car is a function of mileage, which in this case we call x, which means this is a function of x, and that's what we're looking for. We want to know if this is a function of our independent variable, which we again chose to be x. So we determined it's a function. Now let's go see if we can look at what the graph of this looks like. Well, we can graph this a couple different ways. The first way is to graph the points that we created over here, 0, 1, 2, 4, 10. And I'm going to create kind of a broken graph. We have our x-axis, which is going to be mileage. And we have our y-axis, which is going to be cost. And I put the little break in there because our cost is starting at 100 and it's going up from there. So we have 100, 101, 102, 103. And this is cost. And then our mileage, we're starting at 0, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now typically when we graph things, especially in math class, we tend to keep our scales the same if we can. It helps with graphing. But in this case, because the y value is starting at 100, I'm going to actually give this broken scale or this adjusted scale on the y-axis just to make the graph a little bit easier. And this is not perfectly accurate, it's just a sketch. So the miles are going up by 1. That's 5. And this is 10. And then I'm starting at 100 for the cost and going up by 1. Now coming back over here to our ordered pairs, let's graph this in a nice, let's go with a nice green. 0 is 100. So at 0 miles, it's going to cost $100. So that's starting there. And then at 1, we had 125. At 4, we had 101. And then that should be somewhat linear, and we can draw our line connecting those points. And at 10 was supposed to be 250, which is pretty close. Again, this is not drawn to scale. A little bit better line here. There we go. So now that we have our line and our graph, we graphed it based on those points in our XY table over here, 0, 100, 1, 125, or 1, 100.25. I skipped down to 4, 101. We can determine the domain and range from this. So let's do that. And then we'll do one more thing before we go, and that's actually turn this into a function just because it's good practice. So domain. Our domain, remember, is all of the input values or our x values. So that's going to be the mileage in this case. And we know that you can't drive negative miles. If you go rent a car, you're going to pay that flat fee. And then if you drive nowhere, that's fine. You're just going to pay that flat fee. But you can't drive negative miles and get money back. So our domain has to start at 0. 0 miles. And theoretically, we could drive an infinite amount of miles, and that looks like this in interval notation. Now, unlike the other domains that we looked at so far, we can't list these individually. I can't say 0, 1, 2, 3, 4, because A, there's no way I can get to infinity. Right? We'll be here forever writing that out. And B, what about those in-betweens? If I go from 0 to 1, what if he only drove half a mile? Would he get charged for that half a mile? How does that work? So another way to write this, which might look more familiar to you, and I'm going to fancy it up a little bit. I'm going to put those squiggly brackets for that set notation we talked about. And then I'm defining my variable x, and we know that x has to be greater than or equal to 0 because we can't go less than 0 for mileage. And there's my domain. My range is going to be somewhat similar in this case. It's going to start at 100, and it's going to go to infinity. And how does that work? Well, remember we said if we drive 0 miles, it's going to be $100. So that's the lowest cost we could possibly have for renting the car, and then it's just going to go up from there. If you drive an infinite amount of miles, your cost would be infinity, and that's what that means. If you don't remember interval notation, these little brackets here mean included, which means we can actually achieve the 0, and the parentheses mean excluded, meaning we can't actually ever reach infinity. That's impossible. So let's say 0 options wasn't an option, right? We had to drive at least 1 mile, or I guess we could have drove half a mile or a quarter mile. I could put a parenthesis around 0, but that means 0 isn't an option. It just means we can get as close to 0 as possible without it actually touching it. But in this case, 0 for our domain is possible, so I leave the bracket there, which means it's included. That's why over here in the set notation, we have the greater than or equal to. That greater than or equal to is that inclusion of 0. And I can do the same thing for my range, but this time I'm defining y, and y is going to be greater than or equal to 100. And that's it. So one more thing, and again, I just want to cover this quick because it's good practice for us, is let's see if we can now write an equation based on this word equation that we have up here. So we know that we said cost was y, and let's do this in this lovely blue color. We said cost was equivalent to y, so that's going to be y equals. The $100 is a flat fee. The 25 cents is per mile. And what did we call miles? We called miles x. So I'm just going to replace miles with x, and all of a sudden we have an equation. I can rewrite this equation using the commutative property, 0.25x plus 100. And for some of you, this may look very familiar. It's called slope-intercept form, and we're going to touch on that a little bit later on in the class when we actually get into graphing. So far we have our domain and range. We did it based on our word problem. So even though that equation that I just boxed in could have negative numbers for our x value, because of the restrictions of the word problem, we can't drive negative miles. My domain and my range were limited.